What's up, YouTube? Humans and animals all detect objects on a daily basis. From cars to trees to even other humans, we detect a lot of objects per day. But have you ever thought about computers detecting objects like we do? That might sound crazy, but currently object detection is found within phones and cars. Object detection is changing the way computers are interacting with the world. And the Viola-Jones algorithm is one key knowledge to unlock object detection's full potential. But how does the Viola-Jones algorithm actually work? In this video, that's exactly what we'll be talking about. I hope you enjoy the video. The Viola-Jones algorithm's main objective is to detect a face. For it to do so, it will initially look at the frontal features of a face. The algorithm examines the various sections of the frontal face image and examines each section, like the green box represented here. It tries to identify any features of a face that is located in that green box. The features that the Viola-Jones algorithm mainly looks for in a face are eyes, mouth, nose, cheeks, and so on. If it does not see any features in that green box, it will move a bit further and try to find the features in that green box. So let's take this first box as an example. In this box, there's just a black blob, which we can't really tell what it is until we see the full image. Therefore, we can say that the first box contains no face. In the second box, we can see a larger blob, which now we can make out to be hair. In this image, we can also see a tan part, which we can also tell is a forehead. Therefore, we can tell that a face is present in this box. So the algorithm will continue to repeat this process of finding the features of a face until it has mapped the entire face. Every time the algorithm detects a face, it marks where it has found it on the picture and keeps repeating this process until the entire face is checked. When the algorithm has finished scanning the face, there are a bunch of boxes that mark where the face is located. The algorithm will then find the average location of where the face is located. How does the algorithm detect the features of the face? Harlech features are a method that allow the algorithm to detect the features of a face. There are two main types of Harlech features, which are edge-like features and line-like features. Edge-like features look for features that have one side that is light and another that is dark. An eyebrow could be an example of an edge feature because the eyebrow is darker than the skin above it. The line-like features look for features that have a line of dark, which is surrounded by light. A mouth could represent an example of a line-like feature because where the lips meet is darker than the lips itself. When the algorithm looks at an area, it first maps out the darkness of that area from 1 to 10, where 1 is the lightest and 10 is the darkest. For the algorithm to determine which area is dark and which is light, it will find the average darkness of that area. If the average darkness is over 5, then the area is dark. If the average darkness is less than 5, the area is light. For example, in edge-like features, the algorithm looks for one side dark and one side light. This is how it finds each features of the face. Finding the average of every single area would take a lot of time and computing power. In order to make this more efficient, a system called integral imaging is used. Integral imaging finds the sum of each square starting from each point. In the image above, to find the value of the green box, the algorithm adds up all the values in the area and creates a new image with that added up value. Let's look at the big image as an example. In the green box, in the big image, the darkness numbers are 3, 3, 3, 5, 5, 5, 3, 1, 2. All of these numbers add up to 29. So in the first box, in the small image, we can put 29. This is more efficient because finding the average darkness of the image is easy since most of the numbers are already added up with each other. Integral imaging creates a faster and more efficient way to find the features of a face. In order for the algorithm to identify the various features of a face, it needs to know what features have a percent darkness and lightness. This is accomplished by training the algorithm. The Viola-Jones algorithm trains by taking pictures of both faces and non-faces. The algorithm will first take the images of a face and look to see what is similar between all the faces. For example, if in an image a person has freckles and another person doesn't, this lets the algorithm know that not all faces will have freckles. Therefore, it will not look for it in the image. The way the algorithm detects these features is by using Harlech features and maps that there's a Harlech feature at that point of the face. The non-face pictures teaches the algorithm what is not a face so it can compare it to the face and find more differences that make a face different than anything else. Every time the algorithm looks in each of the boxes to look for the features of a face, it would take a lot of time and computing power to look through hundreds of features. This is where cascading comes in. Cascading works by looking for one feature, and if that feature is not found within the box, the algorithm will then move on to the next box. However, if the feature is found within the box, the algorithm will then look for the next feature. Let's suppose the algorithm is looking for a nose. In the first box, the algorithm does not find the nose, so it then starts looking at the next box. In the second box, the algorithm finds the nose, so it then starts to look for the mouth within that box. Cascading is helpful because instead of looking for every feature, even if one is not even there, it will move on to the next box, therefore saving time. Object detection provides intelligence to applications that most of us use every day and is transforming the way the computers can interact with the world. Currently, object detection helps people and companies in various ways. Object detection is used in self-driving cars and drones to help them move without hitting an object. It is now having a widespread use in phones for facial recognition. There is a lot that object detection can help with in the future, and the Viola-Jones algorithm is one key knowledge to help us unlock object detection's full potential. Thanks for watching the video, and if you enjoyed this video, please make sure to like the video. And if you're new, please consider subscribing to the channel as well. If you want to see me make another science or technology video, please comment it down below. If you want to learn more about the Viola-Jones algorithm, I'll have an article in the description where I talk about how the Viola-Jones algorithm works as well. Thanks for watching, and see you guys next time.